All right, good evening, everybody. Welcome back to another vBrownBag, the weekly IT video podcast, where we bring you experts in the wide world of technology to talk about their favorite topics. Kind of like a show and tell for tech geeks that want to learn something new. This evening, we are continuing both our Python series and our Infrastructure as Code series in one amazing human being, Rosemary. Tonight, she is going to talk about, can you test your infrastructure as code? Rosemary, how are you doing?
I'm doing great. How's everybody else doing?
We are doing fantastic. Thank you. Before we get into it, let's do a couple of show notes. If you are in the live studio audience, you can post a question in the chat channel or in the Q&A. Shala, Roger, and I will be watching to pose your questions to Miss Rosemary as we go through this presentation. If you are online, you can find us at vBrownBag on Twitter, and you can also hashtag us on any of the social medias. We have them all up, Blue Sky, Threads, all of the nonsense. It's ridiculous now. There's no way to keep up with all these different things. So, folks, how's everybody doing tonight? That's you, Roger. You, Shala. Anybody? Feel free to chime in here.
Yeah, I'm great. What about you, Shala? How you doing?
I'm good.
That is awesome.
I am good.
Awesome.
If you're both playing Diablo on the other screen, I'm gonna be so mad right now.
You already know I'm Zelda all day.
That's right.
+1 to Zelda.
Actually, yeah, I've got 120 shrines done now. So I've got I think I've got like 27 hearts. I'm doing pretty good in Zelda too. It's been amazing. All right, we've got some folks in the audience, and I'm still sharing my screen. Why am I doing that? I got to stop. Miss Rosemary, if you want to grab the share, how have you been doing? What have you been up to? You are I don't know if you've got like an intro deck, but I want to.
I have no deck.
I want to wax amazing about you. You are a known author. You are an amazing speaker. I've seen a lot of your stuff, and I super love it. How are you doing this fine evening?
I'm doing pretty well. Had fajitas for dinner, so that's kind of nice.
Nice.
Homemade.
+1 fajitas.
Yeah, fajitas. And talking about testing, which is actually I'm one of the people who really likes talking about testing. I don't know why. I just find it really fascinating. Testing theory is really interesting to me.
It absolutely is. We've had a number of folks on the Python side of this. I was talking to you about this before. We've got a number of folks on the Python side who have been talking about testing. This is going to be a fantastic melding of the topics, because we've got IaC, we've got testing, we've got all this stuff, and we've got Python enthusiasts and Terraform enthusiasts in the audience. So this is going to be fantastic.
Nice. Yeah, so I guess I didn't have an intro slide, so I guess I should make an intro slide or a quick intro. I'm a developer advocate at HashiCorp, and as Chris mentioned, I have a book on infrastructure as code practices and patterns. Basically, it's a collection of short stories on things that worked, things that didn't work, and things that I discovered along the way. Even though it's got a lot of examples and a lot of the theoretical examples are fictitious companies. A number of those experiences were compiled from a lot of the work that I've done in the system space. I was a developer at some point. I'm a terrible developer, but I still learned a lot from that experience. And I guess now I do a lot of work on infrastructure. And at HashiCorp, I primarily focus on Terraform, Vault, and Console, a little bit of Boundary, but always learning everything inside. So here we are.
That's awesome.
I think we're set. Okay. All right. So I guess before we dive into infrastructure as code, I'm not going to talk too much about infrastructure as code to start, but what I did want to start is the title of the session or the podcast episode is, can you test your infrastructure as code? And really, yes, the answer is yes. We kind of got to this point that we can acknowledge, yes, we can test our infrastructure.
That would have been a really short episode if the answer was no.
If it was a no, then we have to
all right. Good night, everybody.
Yeah, good night. Mic drop. Everybody log off. But I think the better question is, should you test your infrastructure as code? Because I think it's hard Testing in general is really hard to justify from an executive standpoint. But more importantly, from a development standpoint, it's really hard to say, I'll spend the time and effort to write tests, right? But I'm not going to go too far into this, but tests are important to help contribute to the overall quality of code. And so writing tests means helping you understand what are some pitfalls within your infrastructure as code that you might be encountering. And I take a slightly different approach to testing infrastructure as code. I think about testing infrastructure as code as moving unknown knowns into known knowns, right? So this is a matrix, formerly a consultant, so love matrices. But the idea is that you have a lot of information in your organization, and most of the time it's distributed across different groups and different parties, right? And so all these unknown knowns are things that maybe you don't know, but someone else knows. And that's siloed knowledge. Testing is the practice of moving siloed knowledge into known knowns, things that you can capture and communicate to someone else, right? And so even though documentation might be, also there for that purpose, as a development team or as an infrastructure engineer or systems engineer, what you're looking to do is take information that someone else knows, capture it in a way that makes sense, and put it into a test so that when someone updates their infrastructure as code, they're able to recognize that there is some knowledge they need to address, and there's maybe a gap here that they should be looking at from an infrastructure requirement. So that's the idea. And today, when we talk about, can you test your infrastructure as code? The answer is yes. Should you test your infrastructure as code? The answer is yes, because you're trying to move all that knowledge that someone else has into knowledge that you share with everybody else. So it's not just testing for the sake of writing a bunch of tests and getting 100% code test coverage. That's not the point. The point is with testing infrastructure as code is to be really judicious about where you apply it and to understand why you're testing something and how effective it is.
Rosemary, where do you see most people having the most issues with, in which particular square here? Where do most companies run into issues?
It's actually the siloed knowledge when it comes to infrastructure, right? Think about it this way. Maybe someone made a network change that was an emergency change on a Friday night for some reason, and it was documented somewhere in their change management system, but it was not communicated to the rest of the team that this change was put through. And so the result is that you're not going to find out that something happened downstream from that until maybe Monday morning, Tuesday morning, possibly a couple weeks after that. And you'll have to dig through all your change management logs just to understand what happened and reconstruct what that change might have been. So a lot of the problem tends to actually be these unknown knowns because they contribute, well, in the infrastructure as code space, drift. They often are responsible for configurations that are out of bounds, like they're not under infrastructure as code management. So they're under more manual changes that you might not be documenting completely. So those are where the challenges are because they're out of the expected or the predictable behavior of infrastructure as code.
Awesome, thank you.
Yeah. All right, so we're going to scroll up to this diagram. This is the testing pyramid. This is a theory. It is not intended for everybody to make all their tests into pyramids. As much as we all like to shape things into nice, neat boxes, the reality is that your infrastructure testing strategy may look a little more like a signpost that's going to topple over any second. Shout out to President Hudson and Zelda, who might just topple over in the sign. So basically, this is a signpost of infrastructure. Everybody's laughing, but so the signpost, the testing signpost that I joke about tends to happen quite a bit in infrastructure, and it's not inherently bad, right? There's nothing bad about it, but sometimes it means that it's expensive or it's costly from an effort to maintain. So a lot of infrastructure, you get manual tests at the top, a lot of manual tests, end-to-end tests quite a bit if you do automate your tests, meaning does this endpoint work? Does this server say running? Integration tests kind of sit somewhere in the middle. Most of the time, integration tests apply to infrastructure modules or separate libraries that are looking at infrastructure components, right? You're testing that functionality. Contract tests are non-existent, and we'll talk about contract tests in a bit, but unit tests are looking at static configuration, static plans, static state. So the idea is that all of these types of tests contribute to an overall testing strategy. It helps you understand what the expected behavior is of your infrastructure and whether or not those changes will potentially affect something, whatever that might be. It could be another component, it could be another resource, it could be some other kind of security requirement that you might be thinking of. The signpost, again, is not bad, but what we really want to think about is getting more nuanced on how we distribute our tests. And so that's where the testing pyramid comes in. The reason why you want to think about distributing your tests in a pyramid form is that as you go up the testing categories, the cost increases, meaning the cost of the resources as well as the time it takes to run them. So you can imagine an end-to-end test, for example, is very expensive. It means you have to put up an entire environment, which could include networking, database, servers, can be pretty expensive. While if you go down to the bottom, right, you want more, theoretically, unit tests, because unit tests are not that expensive. They don't require resources, hopefully. They don't require large environments in order to run. Now, that's not perfectly the case. This is, again, theory. In practice, it doesn't actually look like a perfect pyramid, but it is a great way to think about how you approach testing infrastructure as code. A lot of what you might think about on the top of the pyramid end to end is something that you're not going to run too much of, right? You don't want to run a lot of endpoint checks in your infrastructure if you really don't have to. It takes a lot of time. It takes a lot of effort. You might only want to do it in production. Versus maybe a unit test, it's maybe worth running as part of a module or part of your actual infrastructure configuration. So that's a caveat to the testing pyramid. Any comments, questions? I can see giggling.
I like the way that you've positioned it in terms of expense. The more you test, the more time and intensiveness it becomes, the more resources you allocate to it. But by getting in at the ground floor, you're actually saving yourself a lot of heartache in the future from a production perspective.
Yeah, exactly. I think that a lot of the industry now, when they talk about testing, they talk about shifting left. And that's exactly where that ground floor or the unit testing layer becomes more of an emphasis, right? The idea is that if you can either mock or dry run without actually creating the infrastructure, you get faster feedback. And it means that you can catch a good portion of changes that might be affecting production or might be affecting something else that you don't otherwise manage. But it's difficult. It's not perfect. It's a very imperfect approach, but you still need to have some kinds of tests. And you also want to understand the kinds of tests and how they're positioned and their ultimate cost, because it is something that is often the first thing to go when it comes to cost. People are going to say, let's cut our testing environments and cut all of this, but it comes at a cost of having a failure introduced into production. So it's
of doing your tests in prod.
We have all these techniques to test in prod. I can go into a whole different session on that. We're not going to cover it here because it is too complicated. And every time I do blue, green, and all these and canaries for infrastructure, everybody's like, why? So we're not going to go into it.
So no chaos testing. We're not going to talk. We're going to skip that completely.
Yeah, we're going to skip that section because that gets too much. Like, I just can't do that right now.
Let's save the question for next time.
Yeah, this is an asterisk for next time. And so I also, one of the things that whenever I explain testing is really helpful for me to also remember is that not all of these tests are going to be for every piece of infrastructure you have. So if you're familiar with Terraform, you have this concept of modules, and modules applies to a lot of other infrastructure as code tools. The idea is that you want to group a common set of components together. Mm-hmm. So when you offer an infrastructure module, you're going to run a different set of tests than your live infrastructure configuration. When we talk about live infrastructure configuration, that's something like a development environment, production environment. These environments are going to use modules, but they're going to be heavily dependent on how the modules are put together, right? They're going to be the end puzzle, while the modules are the puzzle pieces. So the kinds of ways that you test the end puzzle is going to be very different than the individual puzzle pieces. So when you think about modules, you're going to think about integration, contract, and unit tests. Integration is testing that the module works as intended. It's functionally the way it's going to be. Contract is really interesting. Contract tests are borrowed from microservices. You can think about contract tests as making sure the module inputs are exactly what you expect them to be and the module outputs to be exactly what you expect them to be. A common example of this might be that a network ID is an output, but maybe your user expects a network name to be an output from that module, and therefore it breaks their Terraform. So you have to think carefully about whether or not the inputs match the outputs to what someone expects. And then unit testing is something that I think is more important on the module level for some functional reasons and mostly for security reasons. Yes, I consider security tests unit tests. I'm sorry, everybody in security. I'm really sorry, but yes, they are a subset of unit tests.
Okay, I'm good with that.
Okay. I thought I would have more debate on that one, but
no, I'm good with it.
okay. And then on the infrastructure live configuration, so production development, et cetera, you'll usually have end-to-end tests. These are going to understand whether or not your infrastructure works. It's easy to say, I created a Kubernetes cluster on this network. It's much harder to determine whether or not you can access an application in that Kubernetes cluster successfully. So end-to-end tests are the ones that help you understand if end-to-end your infrastructure is working as expected. Integration is also something that is somewhat valid for infrastructure. Integration tests for infrastructure sometimes are, you're going to take it as a way to examine independent infrastructure that's not in a module. So if you have a one-off server that is not using a module and you don't know if it works, maybe you write an integration test for it. And then finally, unit tests for infrastructure, again, security purposes, but also it's a great way to just check for certain dependencies, requirements, things that you expect to see in your Terraform or your infrastructure as code. We're going to go into code because it's a lot easier to see this in code. But I have to set this first because it's a lot harder to describe what's going on in the code without some background into what tests are and why we divide it into this manner. Scrolling. All right. So I'm going to show 2 ways. There's the BYO version, bring your own test framework, and then there's Terraform. Terraform has some things that are not native to it, some things that are native testing to it. So I'll show to a certain extent the what there is available. And then I'll show the BYO version as sort of like, here's a way that you can think about it separately. But in testing, there was a Python, I heard there was a Python testing episode.
There are actually two testing framework Python episodes coming up.
All right. So testing frameworks are going to be written in Python. You can use any generic testing framework. Really, what you're looking for is functionally a setup and a test capability and a teardown capability, right? So a setup, test, teardown. The reason why you do a setup and a teardown is that sometimes you don't want to keep that infrastructure around. So a setup is going to do a Terraform apply. It's the equivalent of a Terraform apply. The teardown is equivalent to a Terraform destroy. And these are fixtures that you're going to find in a number, these are functions you'll find in a lot of the testing frameworks that you'll have to put in place. So if you do bring your own, you'll have to create a setup method and you'll have to create a teardown method. And then you'll write the tests that run in between. But let's start from the bottom. So let's talk about unit tests. Unit tests. Unit tests are going to test static configuration. So this is in Terraform, this is going to be the .tf file, or this is going to be the tf state file that you have. This is a bit of a strange request because most of the time unit tests are supposed to be run independent of any network access. You're supposed to be able to run it independently. However, it's really difficult to run a unit test, or it's difficult to run a unit test on all plain static configuration and not understand what's happening in state sometimes. And I'll show an example of this. So it's not truly a unit test, and that's what's sometimes they're going to be like, oh, why, I want it to be a unit test. And the thing is, you can't really make it a perfect unit test, unfortunately. You can get very close, but you can't make it a perfect unit test. So we'll start with the static configuration. What can I check? So you'll notice that I have a test network.py. This is in the generic Python testing, but that's less the concern. We're going to look at vpc.tf. vpc.tf has a definition of a VPC as such in Terraform. So this is in HashiCorp configuration language. And what I'm going to do is, in my testing framework, I'm going to pull in the HashiCorp configuration language file, so the Terraform file, and I'm going to parse it. Testing in infrastructure as code is literally parsing the values from a unit testing standpoint. So in this case, what I'm going to do is pull in the information from the Terraform configuration about the module and the VPC. That is module, VPC. And I want to know whether or not I enabled DNS hostnames on it. So I enable DNS hostnames, true here. And I'm going to write an assert statement that checks whether or not I enable DNS hostnames equals true. This is really all of it is really just parsing the HashiCorp configuration language or the JSON that you have generated. That's effectively what all infrastructure as code testing frameworks are pretty much doing from a unit testing standpoint. So you can, as long as you're able to understand the structure and the schema of all of these attributes, you're going to be able to write a test for it, whether it be using a behavior-driven a BDD. What is it? Behavior-driven develop? Given when then? BDD framework like Cucumber. You can use that. You can use this more generic testing framework, PyTest. You can also use Rego, which is, OPA, which is the Rego language. So if you're not familiar with OPA, it's Open Policy Agent. This is more popular in the Kubernetes space, but a number of policies are now being written in OPA. And so, for example, OPA itself could also parse JSON or parse HCL if you really wanted to. You do have to do some conversions to get it to JSON, but effectively you're parsing any static configuration. Any questions? Comments?
I have so many OPA jokes, but I can't make them. I will keep them
not?
to myself. As a Greek, I feel the immediate need to start breaking dishes, but now that you've said OPA, but
Yeah. I mean,
there's no dishes close by.
Oh, one, I could write a test for a dish. Would that help? Pseudocode it.
So you're using assertions for the unit tests, and I'm assuming you made that distinction because as we progress in this, the different types of tests leverage other mechanisms.
That's correct. Yep. Assertions, I mean, most of them will be assertions, but a lot of them will have additional logic that you'll need to add in place as well, which is the more difficult part at times. So that's something to keep in mind. The one thing that I also wanted to note is that this is showing in PyTest, but there is actually internally a way that you can do these checks in Terraform. And in Terraform, they are in the form of variable validation or preconditions. So preconditions, let me see if I can find a good one in here, but preconditions are a lifecycle block that you can add. So if you look at this lifecycle, for example, lifecycle precondition is something that you can add to resources and I think also data sources, but I can't entirely remember. This is something that is almost like a testing assertion, but built into Terraform. And so you can add this thing called a precondition. The precondition runs before the apply, and you can check an attribute related to that resource. So for example, I'm going to check whether or not this random password for a database length is greater than 3, right? Something like that. Actually, it's this one, sorry. This one here, it's something for the database is like greater than certain number. So this means that I can check for security requirements. I can check for certain attributes. So the same thing on this VPC, this enable DNS host names, I could do something like lifecycle precondition. And when I do a precondition, I can say the condition must be module.vpc.enable DNS names, host names. I don't think preconditions actually work for modules though, so I have to double check on that. So you might not be able to do it on the module level, but you would be able to do it if you had a resource VPC and not the module itself. So that's something to keep in mind. So a number of these, for example, data availability zones, you could also check for, right, this is sort of a linting kind of rule. As a unit test approach, you might say, I'm not just checking for the correct attribute or a standardized attribute like enable DNS host names or encrypting a disk. You might be able to, you might think about testing for specific practices. So for example, in my VPC, I am not going to pass in US East 1A, US East 1B, US East 1C. I'm not going to hard code that in. Instead, what I'll do is I'll use a data source with the which will dynamically retrieve AWS availability zones and pass that in. And so as a practice, right, maybe I want to communicate to Roger that, hey, like, I want to make sure that we always use data sources and we don't use hard-coded values. So let me check and make sure that the data.aws availability zone string is something that everybody defines as part of this VPC module configuration. So that's something that you can also check for. Unit tests have a way of allowing you to check for requirements that you expect best practices from other people or your teams. It also checks functionally that there are certain attributes that you need enabled or you don't need or you don't want enabled for either security requirements or functional requirements as well. All right, there's another nuance to unit tests, which kind of border between unit and contract, but the other part of a unit test, and I still consider it a unit test, and I mentioned it before, is testing state. And the reason why I think about testing state as unit test is that certain pieces of logic that an infrastructure's code tool will generate is only something that you're going to see the results of in state. So a good example of this is how many people or how many people here are brave enough to understand what the CIDR subnet function is subdividing. Yeah.
It's Charlotte time right now. It's Charlotte time.
She is our resident network pro.
It's a trigger. That's what that is.
Yeah, see, this is one of those things that like you don't know if this is right. I don't know if this is right. No one knows if it's right off the top of their head unless they really can subdivide these things. And I know people who do it really well. But I defined these subnets, right? I said, okay, I want to subdivide 10.0.0.0/16 in these random things. Maybe I copied and pasted it from somewhere, but I don't actually know where it's going, what it's subdividing to, because I'll slice it. It's going to take this CIDR block and subdivide it into an array, and then I'll split the array amongst my private subnets, public subnets, database subnets. Awesome, but I don't actually know what the size of the CIDR block is, right? I don't know how many hosts I can put in it. It's not something I can calculate off the top of my head. So this is something that I cannot calculate or I cannot test for in static configuration that easily. It's something that I'm only going to know when I see it in state. So that is where you have to generate state. And this is where it gets a little bit more difficult at times. When you generate state, you have to retrieve it from a specific subset of commands. So you do a Terraform plan and it does this output, and then you output it. So this is a large example of that, for example. And this is the state scheme, JSON schema that Terraform references when it's trying to make comparisons from, let's say, its own state and then the API, the AWS API, for example. This is one that has some redacted sensitive information so that I don't accidentally print some passwords on the screen. But you get the idea. All of this stuff is defined in state, and I'm then going to retrieve certain values from this state. So if I go to VPC, let's see if I can find it. CIDR blocks. Can I find it? Or it's a subnet. And it is rather large. So if you do want to test this, it is a very, very, very large configuration that you'll have to go through. Let me see if I can find the subnets. But maybe the idea is here, I'm going to try to find the subnet values and check that the net mask, the mask is correct, right? I just want to make sure that all of the subnets that are in my state have a /24, because that's what I expect them to be subdivided to. So in order to generate this, here we go. In order to generate this state locally, you'll have to do 2 steps. The first is Terraform plan, and then you do this out, and then you can do an out file, right? Something like this. And what this will do is generate a binary file for you that has all of the plan information in it. And then you'll do a Terraform show and then pass in the file. So it'll be sort of JSON TF plan, something like that, I think. But this is a 2-step process if you're doing open source Terraform, or you have local state, or you have remote state in S3. If you have something like I have set up, which is in Terraform Cloud, I have to actually retrieve it through an API. So I have to do an API call to retrieve the state from a remote endpoint. But if you were to do this with open source Terraform, and you're doing this in a CI/CD pipeline, or you're doing this with OPA, open source, then you would want to do this 2-step process of doing the plan and then showing that plan in JSON form. So this test is a little bit more complicated to write because of the setup, right? So you have to know where it is in the JSON, this JSON state. You have to identify the value that you're looking for. But once you do it once, it allows anybody else who's going to be configuring a VPC to understand what they're trying to do with the subnets, right? How many subnets you're going to have, how many hosts you're going to be able to put in that subnet. At least you'll have that check in place functionally. So it's not a problem. This is maybe more of an issue if, let's say, you have specific requirements for your CIDR blocks that you're passing to your VPCs due to peering purposes and stuff. You want to double check that nothing's overlapping, right? So that's one reason why you might do it. Similarly, you could put this state testing ability in a precondition or what is a postcondition. So similar to what I showed before with the precondition, you can also have a lifecycle block and add a postcondition, and the postcondition would be doing after the apply, however. So with state testing, you still have to have access to the AWS API. You still have to put in correct credentials in order for Terraform to connect to things. You cannot do it in isolation. You cannot run them without a network connection. So it's not a true unit test, but it's, I think, more valuable in some ways than parsing the individual static configuration that you might have.
From the perspective of your testing paradigm, do you prefer to use the things that you can do preconditions and postconditions in Terraform, run those tests, and then whatever you can't do, you use PyTest as a catch-all, or do you prefer to do them all in one testing paradigm?
It's a good question. I personally like doing everything in PyTest, but that's because I'm more familiar with generating and parsing the state output as well as the static configuration. And I like having all of the types of tests in one uniform language for me to understand. However, there are a lot of folks who subdivide this into 2 things. So they'll do post conditions or preconditions for if they're not so familiar with testing, for example, and they want to do something within Terraform for some light checks that might involve, let's say, checking that there's 1 or 2 attributes that they're really looking for, and it's important for them to preserve. Other folks will do OPA or some kind of policy engine, and then they'll use PyTest or Go test or or TerraTest, right, to fill in the blanks for every other kind of test. So unit tests tend to be in a very different kind of language because there's a little bit more support for a DSL, for a domain-specific language for infrastructure as code testing, versus some of the other processes where the other testing approaches need a setup teardown mechanism, and that's not something that's always supported within a DSL framework, right? It's something that you might need to do within a CI/CD pipeline or within some code.
Cool. Thank you.
Cool.
Yeah. Let me see. There's probably a couple of modules. We'll talk about modules. All right. So the other thing that you can do that's even fancier, and the reason why I go through unit tests in greater detail is because I think it's very underrated. And people are like, why do I want to parse static configuration? It doesn't really matter to me. You might parse static configuration, like I said, for security requirements or functional requirements. Parsing the state and testing the state is really helpful to understand some of this complicated logic that you might have. So maybe you have some count blocks or you have for each, and you're just really not sure whether or not you reliably computed the correct information into the right place. Then you might do some unit tests related to state and understanding whether or not those attributes have populated correctly. The third thing that you might actually think about from a unit testing standpoint, and actually, I think it's more of a contract test, actually. I mentioned checking that the inputs match the outputs. One of the things that is a really common situation that I see is that you're passing dependencies between resources. So an example of this is, let's say you have a Kubernetes cluster. How do you know that the Kubernetes cluster was created on private subnets, right? You might just say, oh, I'll just put them on public subnets somewhere. And the thing is, in AWS, there's no such thing as I labeled this explicitly a public subnet. You really only get this attribute that says something along, I think it's something like map public IP on launch. There we go. There's one attribute that tells you whether or not it is theoretically a public subnet. And if you're trying to create an EKS cluster, and I'll pull up the EKS module that I've used, but if I am looking at this EKS module, I'm passing in these subnet IDs, and right off the bat, because I'm using this VPC module, I know it's a private subnet because it's labeled as such, right? But if you can imagine, if I just passed in some subnet IDs that I got from somewhere, I wouldn't know if they were public or private. So how do you know that your EKS cluster, your Kubernetes cluster, is on private subnets? Well, you don't. And maybe you want to validate the contract between the two. You want to validate that whatever you input into the Kubernetes cluster module is indeed a private subnet and not a public one. And so in this case, I'm using OPA. There's also an equivalent in PyTest as well. But I'm parsing the state file again. And what I'm looking for is whether or I'm retrieving a set of subnet IDs from the VPC. So that's the first thing. And the next thing I'm doing is retrieving a set of private subnets, right? So these are all the private subnets from the VPC. And I'll compare the subnets that are under the EKS cluster with the subnets with the private subnets of the VPC. So basically, do these two lists match each other? And if the answer is no, then I let my engineer know, hey, EKS cluster should be in private subnets. This is all fancy math, or it's not math, it's collections logic within Rego. But the equivalent does exist, right? You could say in Python or any other language, you can test and see whether or not your cluster has matching subnets. So for example, here's a ton of logic that I have here, but I'm going to check if the Kubernetes cluster subnet IDs match my private subnets in my VPC. And if it does, then I'm fine. Otherwise, I'll throw an error and say it's not matching. So 2 ways to do it, 2 different languages, but both looking and evaluating for the same kind of logic. So we're assessing whether or not the contract of an input matches the expected input and not something else. All right, I'm going to go back to the pyramid for a second. Also, do jump in with other questions or comments.
So this
I have a
is
question.
super awesome. Oh, go ahead, Sean.
I have a question going back to what Chris asked earlier about like deciding which framework to use, right? If you wanted to use, say, keep it all in OPA and hi, I joined late. I'm sorry. That's so.
Is my mic still on? Oopsie.
So like, I like the idea of testing in say a programmatic language, because then you can add extensions to it, right? Like, I'm just thinking, if one of those test steps failed, maybe you could send a notification, send an email, do something, write something to a file somewhere and send that somewhere else. Like, is there any capabilities with I'm not super familiar with OPA, but is there any capabilities of that? So that's question one. And then question two, I hope at some point, is there like a place, like a beginner's guide to learn how to test with any of these for Terraform?
Yeah.
That you could share with us?
Yeah, so let's start with the first one of like whether or not you can aggregate it. There are different ways that you can aggregate it. Most folks who use OPA, for example, they'll generate the test reports because there's an OPA eval command. And what that will do is output an aggregate, basically an aggregate array of all the information of this test that passed, test that failed, right? And so that's one way that you can export that or write that somewhere for you to use. Usually they'll do that in a CI pipeline. They won't necessarily do it locally. There are some tools that allow you to do it locally and sort of write it somewhere, but most of the time you're going to be writing it and you're going to have that information in your CI pipeline as a step. So similarly, this is one of those things that I'll show here. I'm using Terraform Cloud, which is the CI approach for Terraform, but you don't have to. But the OPA, OPA tests here are being run within Terraform after Terraform plan. So it automatically does that, and it will run these tests. Now there's no output to display because they all passed, but if they did fail, you'll see the test, sort of a test output with that error message. And so that's where you're going to find a lot of the aggregate information if you're using different frameworks. Now for PyTest or any other generic programming language testing framework, you could use a JUnit. You could use any of them that aggregate into a more comprehensive testing report and then export that as well. And you would do that in CI pipelines or whatever tool you're using. The preconditions and postconditions, which I showed before, the tricky part about preconditions and postconditions is that they are in Terraform. So in Terraform, if you're running them, they will be checked, right? So you'll only really see them at the plan. You can assume that all of them pass, and then the plan will show you that there's an error, right? So in this case, there's a postcondition that failed. I put in a postcondition that double checked that the version that I want to use is matching the recommended, right? So this ensures that I check for certain versions and make sure that I'm pinning them, but also that I'm using the most updated one. So in this case, you can grab it and aggregate it from plan if you see any errors. The alternative way of doing this is to do what is called continuous validation in Terraform Cloud. But the continuous validation is more of a check that just sort of goes through and looks at everything. So you'll notice that one of my checks, my vault status failed, right? So that's telling me that it's a failure, and then I can get notifications on that. But a lot of this is going to be embedded into CI frameworks. Sometimes there are testing frameworks that are out there that apply to both sort of application code as well as this approach, infrastructure as code, because you're using the same thing, right? So you can use the same frameworks there. But there isn't really a great open source one that I can recommend across the board that either for OPA specifically, a lot of them you have to kind of plug in yourself. Oh, and the second question, where to find it? So there is a blog that I have out on testing Terraform. It's not going to go through the specific details. This one uses more about, uses Sentinel, but it is a more straightforward breakdown, I think, of how to think about this specifically in Terraform. I think it is due for an update. Eventually, I will need to update it to include post conditions, preconditions, and everything else. These are embedded in Terraform now, so you can actually use them for certain functions like unit testing, contract testing, etc. For example, there's variable validation as well in Terraform that you can use for some form of unit testing to check that your inputs are correct or as expected. And that's a little bit easier to use than, let's say, writing and testing a bunch of tests in a generic testing framework.
Do you have any GitHub repos that individuals can look at for testing or that are publicly available?
Yeah, so this is the one I'm using today. This is my mega demo repo. View with caution. It is a mega demo repo. All of the tests are under infrastructure. So I have policy tests as well as unit and end-to-end tests. The example that I have, I showed today of Terraform AWS boundary is actually a live test, is a test I use for a module. So this is actually, these are more structured tests for a module. And if you really want to get, this is my resource compilation with a large set of tests and various resources on testing frameworks, as well as some that are Terraform specific, some that are related to server testing, others that are Kubernetes related, and others that are mocking. For mocks, for example.
And for everybody watching this not live in the future, all of these links will be in the show notes of the YouTube video.
Well, we're sharing. Hey, they didn't
yes,
show
we're sharing. That's what we do around here.
Share, everybody share. All right, so I'll go into module and integration testing. I know we don't have that much time, but I'll go into it briefly, just because there are two important steps to make sure you have when you're doing module integration testing. So modules you can use unit tests for, right? You can check statically that certain things are defined. But really an integration test is important to understand whether or not the resources that you put into the module actually make sense and they get created. So in this case, I have this module that I actually use on a regular basis. And this is a module that creates boundary open source, but it also creates HCP boundary, and it uses HCP, which is the cloud platform boundary, as well as a self-managed worker for it. So basically there's a lot of functionality packed into this module. So the result is that I usually have to test a couple different things. And so when you do an integration test for modules, you're going to look for a setup command, and then you're going to look for a destroy command or a teardown. And if you're not familiar with PyTest, it's all right. But the way that PyTest does the setup and teardown is that you do a setup, and then you write a yield, and then you do a teardown. So the yield is where all the tests are happening, and that's where things are going. So I'll assert, the first assert statement initializes everything. So it sets up Terraform. This is running Terraform init. I had to write these utilities myself and wrap it around the Terraform CLI. So word of caution around that. You may end up putting this in a bash script, or you might end up putting this in a CI framework. So you don't have to do a lot of this you don't have to handle contexts in CLI threads. Passing, CLI subprocesses and stuff in Python or in your testing framework or programming language interface. So it will also then run the Terraform apply, and it will check a couple things. It will check that the apply ran successfully. It will check that it has no errors. So standard error doesn't have anything in it. And it also checks a very important bit of it, that ensures that boundary is running. So you could create these modules, right? And you can create a bunch of these components, but you won't really know whether or not some end result that you wanted actually works. I still consider this an integration test because it's not end-to-end every single piece of infrastructure resource that you have. It is focused specifically on whether or not this module works. And so when I run this test, it will test that boundary is running, and it will ensure that I can access it, right? And that I'll assert that the response code is 200. Yeah, so keep in mind, this is not something that you can easily do within Terraform. There is a way that you can do it in a post condition. And so a post condition is something that you'll do to run as a check after an apply. The good thing about a post condition is that it runs after the apply. So it only will check after all of these resources have been updated and configured. The downside to the post condition is that you can't do really fancy logic, right? You can do, let's say, HTTP calls out to your target endpoint that you want and check that you get a 200 back. That is something you can do. And so, some of this code, for example, has a post condition that will do that. So for example, here, I'm checking to make sure that my Kubernetes version that I'm applying to AWS is not going to be the latest Kubernetes cluster version, right? I want to be a minor version behind, just from a functional standpoint, because I don't want to accidentally upgrade it and find out that there's a schema or an API change. So this post condition is nice because I do make a call to the GitHub API, and I check whether or not the cluster version is going to match the response, the tag name, right? The latest tag from GitHub, which is kind of nice. But this is an HTTP call, right? This is a call out somewhere. It's not really going to handle any complex logic. So what I mean by complex logic is that if you had created a database, for example, and you wanted to maybe add tables to it, do some configuration as part of your module, that's maybe a part of a provisioner or something in Terraform. If it's not something that is going to be directly easy to test, and you have to have a bunch of logic, then a post condition might not be the right fit. So use the post condition here in Terraform if you do want to do a quick check for an HTTP endpoint or something, or you want to retrieve something from your cloud API status, right, using a data source. But if you wanted to do more complex stuff, like double checking that a series of things is in place, or you have external logic that needs additional parsing, you might not be able to accomplish that in a post condition. All right, and I'm going to wrap up this last bit, which is end-to-end. Integration testing is something that has a teardown step, because usually you want to save money. I don't know any other way to say it, but you don't want to keep a long-running test environment sometimes. In the case of modules, for example, you maybe only want to create the servers. You might only want to create the Kubernetes clusters. You don't want to create the network every time. So you'll do a teardown to just take away the servers, take away the Kubernetes cluster, take away Lambdas or whatever, and make sure that you're saving money. So teardown is pretty common. But in the end-to-end space for testing, you're just going to do the setup and test. You won't really be doing a destroy. So in this case, the equivalent is apply, checks, and post conditions. One thing I didn't really talk about, but I did show a little bit of, was this check from this check block. So this is a newer thing in Terraform 1.5, but there's a check block that is available now. Check blocks don't fail plans. Check blocks are just there to check stuff. So in this case, I'm checking whether or not the vault status that I had, right, is 200. And in this case, it's 473, which means it's on passive standby. And so it tells me that, hey, vault has an unhealthy status code. I should be checking for stuff. But it is a warning. It's not going to block a plan. It's not going to block the apply, fail the apply. It just lets me know that here's something that I should be aware of functionally. And so that's why it's pretty good for end-to-end tests, because it's not going to block you from applying the change, but it will tell you that something is functionally not correct. And it's something that you can maybe think about doing in case you don't have it tied to a Terraform resource somewhere. You just want to check that an HTTP endpoint is up and running. So this is something like in applications running, your load balancer is configured correctly, the DNS, the DNS for something is configured properly. You're just going to run a quick check. It's not tied to any specific Terraform resource, so you don't want to do a post condition for that. So that's a quick note about end-to-end testing.
Does that check block, does that apply immediately after the apply phase is done? Or can you control like a delay, or would you have to control a delay via some other mechanism, like a specific resource that's being built, right? The kind of scenario I can think about is the common scenario of I'm spinning up an EC2 and I'm setting up some user data, and then that user data takes a while to do something. You can set wait for, or there's like an ELB healthy threshold you can set on like an auto scaling group to like wait for something to register to the load balancer. But even then, like the app may still be doing something. Is there a way you can like kind of wait on that check block?
Yeah, so I don't think the check blocks have wait meta arguments. They only have depends on. So they don't have the lifecycle like wait for, etc., unfortunately. And so the check is not going, when I say it's not going to block anything, it runs typically during the plan phase. And then after that, it'll run the apply phase again. And the result is that you're really, it's pretty much going to fail if nothing exists, right? During the plan phase, and then you'll only really know whether or not it works after the apply. There's not a mechanism to do a wait for that I can tell, and I'm pretty sure it didn't map the meta argument across. And that's where the limitation, I think, exists for a couple of the native Terraform blocks, like post conditions, preconditions, and checks. And these are things that you do want to do outside of it. So that's where I tend to favor a generic testing framework, whether it be Go, Python, or something else, just because then I get more control over some of these order of operations.
Makes sense. Yeah, thank you.
Yeah. That is all I had. Any other questions?
I have a lot of homework.
That's what I was thinking.
One of the things, test is one of those things that I can spend 2 hours on, and everybody's like, what are you doing? This is a very short, I hope somewhat helpful introduction into testing with all the various options. But yeah, testing is tough.
I love whenever I end one of these episodes and I'm just like, man, I'm stupid. Because it just lets me know that there's so much more out there to get into with all of these things. So I appreciate you making me feel dumb, Rosemary.
I want to do that though. I don't want to do that.
It is a good thing. This brings to light a whole bunch of stuff so I'm currently studying for my Terraform associate, and I'm getting into the weeds of all the things, and this is yet another facet of stuff that I need to take into consideration. So having an episode like this where I see somebody that's basically a master at this, and it's fun to watch. But it lets me know that, I got to crack the books as soon as we get off this thing.
I don't think it's in the exam. I can reassure you it's not in the exam.
Not in the exam.
I know it's not in the exam. This
Maybe.
is something that I want to learn because it's just fascinating. I love new knowledge like this.
Mm-hmm.
Yeah, I had the same feeling where I'm like, more homework. This made me warm and fuzzy because, and I'll keep saying this, Roger, I have like another 6 months to claim I'm new to cloud.
Come on. I gotta wait.
and I need to stand up Terraform for something I'm working on that is not currently using Terraform. So this was like so on point for me right now.
Awesome.
Yeah. Awesome.
We were supposed to be studying together starting January. So she's telling me she's pushing it off for another 6 months. Okay.
I had to go do something.
Rosemary had me at precondition. I was just like, precondition, what?
Yeah, and something that testing is one of those things you don't really need right off the bat, right? If you're just starting it, it's not the beginning. Testing starts to become more of a problem or more of a necessity when you're collaborating with multiple people.
Yes.
And that's where things start to fall apart. If you don't have testing, then you have not a great way to communicate to people that, you know, there are being changes made or there are best practices to consider. And there are patterns that people should be thinking about. So testing's, I think, more documentation and knowledge than it is the functional, like, this is exactly what has done.
When that developer writes that IP address, 182.6310. You're like, wait a minute. Do you not know how IP addresses work? That's literally happened to me. That's happened to me like 10 times. Where I was working with developers and they were just like, we just increment by 1, so it's 256, right? And then it's 257, and then it's 258, and then it's 259. I'm like, whoa.
Just stop. Nightmares.
Giving me flashbacks right now.
Awesome. Ms. Rosemary Wang, this was fantastic. I super appreciate this episode. This is right in the wheelhouse that I want to be in. So seeing you present on this is just, I'm inspired. Thank you.
Exactly.
Thank you for listening to me prattle on about it.
Oh, yeah.
No, it was informational. I'm sorry. That's why I was so quiet, because I'm like over here taking notes and being a learner.
So we are gonna post a link to the book as well. I highly encourage anybody that's interested in this in grabbing it. It is a fantastic read, and it is deep. It is as smart as this presentation was, and even more in depth. So yeah. So
it's already in my cart. Yeah, it's already in my cart. Like, I started looking through the contents. Just when she started popping up the slides from the Matrix, I was just like, this is speaking to my spirit right now. Because I'm doing a ton of DevOps. Yeah, and I love it. So I'm just like, because I'm doing a ton of DevOps right now. So yeah.
Awesome. All right, folks. Well, we have reached our hour. Rosemary Wang, thank you so much for coming on. Roger, Shala, Sean, thanks for finally showing up, Mr. Doyle. I appreciate you.
There's that smile.
I was running late. Sorry, man. Sorry. I apologize, Rosemary. I'm sorry. This is super. Yeah, this is really great. Thank you.
I also love giving Sean a ration of crap whenever I can. So this has been Christmas for me. It's knowledge, and I can give Sean crap. I
actually did that on purpose, so you didn't have the wrong picture of me in the intro. I'm sure you still left it in there.
I totally did.
You left it in there.
All right, folks. Y'all have a wonderful evening, and we'll see you again next week.